Good afternoon, everybody, and welcome. So coming up over the next 30 minutes, we have our live event here at the Engineering Technology Group, and it's called Probing Questions. I say 30 minutes, but it may be 45 minutes, depending on how interactive you are. So the focus of today's show is ultimately to demonstrate, and we will be having a live demonstration of in-process measurement, and we'll be doing that on a QUASER machine, or as we're calling it, closed loop. And we're doing this in partnership with BLUM as well. And we've got David Mould here, who is ready to answer all of your questions. So ultimately, what is the problem that we're looking to solve today for you in today's show? Well, it's quite simple. If you have to access your machine to either measure a part, check a surface finish, or set a tool, then think again, because in today's show, we're kind of trying to improve your efficiency and reduce that operator intervention. We would love to hear from you today. This is a live event, so we would love for you to get your questions in, as we always say this during live shows. We know shows aren't quite there yet, but this is the best way to get that message across that, you know, if you do have any questions, you can send them in. Let us know how you are measuring your tool. Did you know that you could check surface finish within the process? And if you didn't, then get those questions in to the team. So, to the left of me, all waiting in the wings, we've got Steve Brown from the Engineering Technology Group. So if you've got any questions towards ETG, the QUASER machine and the whole process, send them his way. We've also got David Mould here from BLUM, and then from MTD we have got Joe and we've got Paul. And I've got a funny feeling after last night's result, there's a reason why they're wearing these shirts, hey?
Okay, guys. Well, yeah. Should we start by talking about football? I think that's probably a good place to start, isn't it?
Definitely, yeah.
Where did you watch it last night, Steve?
Well, I was at home with the wife and kids.
Any good cheering going on? Any good
Yeah, plenty of banter, and from the 14-year-old, we had to calm him down and peel him off the ceiling. So yeah, it was a good night and all.
And expected result, in your opinion? Did you think?
I knew what the score was going to be. Yeah.
Confident man, just like when you're getting orders for machines, isn't it? David, where did you watch it?
Well, obviously I work for a German machine tool company, so I have to be a little bit sort of cautious here. But so I sit sort of on the fence a little bit. But 2-0, come on, great result.
And Joe, yourself, where were you?
Oh, was there a football match going on yesterday?
There was.
No, fortunate enough to be at the stadium with yourself, Paul. It was a great day, great evening, wasn't it? Well, great day.
It was superb. We were at Wembley. They often say that you need skill, luck and opportunity to win big games, and I think we had all of that in an abundance.
Probing question, Paul.
Go on then.
Was it the best day of your life?
Other than 3 other very memorable occasions.
If your wife isn't watching.
I'm sure she is, and that
bet
was a
she's
better day
watching.
than yesterday. Yeah. So, what's going to happen in the next round, though, guys? Do you think we're going to do it? Do you think we're going to go all the way?
I think so. I think we've got a good chance if we turn up how we left the last game.
Yeah.
As long as they don't drop the standards. Yeah, I think we've.
And David, even though you're working for a German company, can you say?
I mean, haven't conceded a goal yet, which is a plus. If they get through the next round, then it's Wembley. So yeah, it's looking good, I think.
The big question: if football really does come home, will it have to self-isolate?
Well, I like you've got number 7, David Beckham, on the back of your shirt, but I'm not quite sure there's a likeness. But you never know. So, what are we going to see in today's show? Let's walk the audience through, David, what they can expect to see.
Yeah. Well, great to be here. It's a wonderful opportunity for us. So we're basically going to use this QUASER machine to show you what is available in today's technology for probing on a machine tool. So a lot of people will probably already know probing on machine tools. We have standard probing solutions on here, but we want to show you the next generation, really, what we term the Digilog range of products. which shows you just how far you can go to control the entire process to ensure that every part coming off the machine is a good part, and you're not scrapping, you're not reworking parts.
Steve, what machine are we seeing this on today? Give us a quick overview of the QUASER machine and why this one has been selected.
So QUASER MV134 is our smallest footprint vertical machining centre. The QUASER brand, obviously we have various other products under our portfolio, but working with BLUM, it's our most widest range of machining centres, horizontals and 5-axis. So it's the brand and portfolio that we use and work closely the most with BLUM.
There's various aspects, isn't there, David, that we're going to cover today, but one point reading on your website that BLUM invented the first laser measuring system for in-process tool breakage detection in 1987. Some history to the company, isn't there?
It is, yeah. I mean, the company's 50 years old, or older than 50 years old now, but we, as you say there, we came through with the first concept of being able to measure the tools optically on a machine tool, so you can measure at rotational speed. And that first system, the laser control, as you say, came out in the mid-80s, really. The system we have on this machine that we're going to be showing today is the latest generation, which is called LC50 Digilog, and it's taking the next level, really, of on-machine measurement.
Yeah, and I know we're just about to press local start, but what makes BLUM different? You keep innovating, bringing these products out, but what makes you different?
I think BLUM has always sort of specialised in process measurement. We have different divisions within the group, but essentially we don't get involved with any post activity at all, CMM and things like this. We purely work on specialising within the machining operation, because machine tool is a pretty harsh environment. It's pretty nasty, and to get products working reliably, accurately within there, we have to really make sure that we protect them and keep them reliable.
And Steve, towards the end of the show, you've got something pretty special to tell the audience, haven't you? Can you maybe whet their appetite?
Yeah, so me and David have clubbed together then, and we've got a promotional offer that we'll announce at the end of the show. So guys, you need to stay tuned to find out what that is.
Okay,
I'm intrigued.
Before we get going, I do want to ask you the question, David, because a lot of people talk about whether you should be setting tools on the machine like we're going to see today, or off the machine. A lot of people will argue that you should be doing it outside of the working area because the machine spindle can still be running. How do you defend that argument? What do you say to that?
Yeah, really good question, Paul. And really, one of the key things I would like to come out of today really is, obviously people understand and they sort of look at setting tools off the machine on the basis that they say, well, to set it on the machine takes cycle time, so I'm using up time where I should be making chips, I should be producing parts. But that's a bit of a misconception, really. They think that it takes a greater amount of time to actually be measuring your tools in the machine. There's, of course, technical advantages to measuring your tools on the machine, because we're measuring the tool that you're about to cut with dynamically. So it's clamped in the spindle, it's rotating at the speed that you're about to cut with, so we're getting a much more accurate picture of the tool that you are about to cut with. But as I say, people kind of think, oh, it's going to take a long time to do this, and I'm better to preset my tools off the machine. Well, hopefully you'll see in this demonstration that it's about to be run now just how fast the new LC50 Digilog is measuring setting tools on the machine.
I always think, though, if a tool wears during a machining cycle, if you're setting them off the machine, you can't detect that, can you?
If you're setting off the machine, you can set the tool when it's initially before you start cutting with it, but exactly that. As soon as you start running it in the machine, you're going to get wear. You've got to keep updating your wear position, so you're producing parts. But of course, the tool can break as well. If the tool breaks, then you potentially waste time, scrap parts. It can be pretty costly.
And the big one for me, you're measuring the tool at its correct cutting conditions. Every spindle, as good as this spindle is, it'll be different to the next machine and the next machine. It removes the variables.
Yeah, exactly. There's a lot of things that can change. Obviously here we're on a brand new QUASER. It's a highly accurate, highly repeatable piece of kit. But people out there are using machines that are 10, 15, 20 years old, so the spindle is not quite as good as it once was. Obviously your tool holder, what tool holders you're using. So if you're presetting your tools, or you've got the data of your tool off the machine, that's not necessarily what you've got actually rotating at 10,000, 20,000. We can go up to high-speed spindles of 40,000 plus. So we're measuring it dynamically. We're measuring what you're about to cut with.
You wouldn't think that you'd need to measure a part that's been machined on a QUASER, would you, Steve? It'd come off bob on every time, wouldn't it?
Well, they do, yeah, but it's just nice to have a record of it, just to demonstrate to your mates how good a QUASER is.
I guess we're checking for, joking aside, program error, operator error, maybe the billet's not loaded correctly.
Absolutely, yeah. I mean, it's not just the fact of the machine itself. It's, you know, billets are coming in or at different sizes, so we need to update the work offsets from that respect. If you're producing cast parts, forged parts, they're not always the same shape, size. So, you know, there's a lot of information we need to be updating there. That's not just about the repeatability of the machine itself.
Okay, now we want lots of. Well, it's the opportunity for questions throughout the show. You can obviously put them on whatever channel you're watching this on. Also, we can give you a shout out too if you're watching as well. But for now, let's get the machine running. Steve, do you want to press cycle start?
Yeah, I'll do the big reveal.
Good luck, Steve.
Glamorous
You
assistant.
can put this on your CV, Steve, once you've done it.
Look at that.
Okay, then maybe David, you could then walk us through what's happening.
Yep, so the first thing we're going to do is set the tools, and what I really want people to notice here is just how fast we're actually setting these tools. The misconception of how long it takes to set length and diameter. So we don't need to have any preset data. We're measuring the tool and we're updating the tool offset straight away.
Just on that, it's a blink of an eye, isn't it? If you blink, you're going to miss it. What is that actually checking? That's so quick.
So it's measuring the length of the tool and updating the length offset, and it's measuring the radius of the tool and updating that to the tool offsets.
Mm-hmm. And you have different technologies in this area. I mean, you also have the sort of the button type solution that you can use. What's the differences between that and this?
Yeah, I mean, with the laser system, obviously we can do things a lot quicker, and we can check a lot more geometry from the machine tool, because as well as setting lengths and diameters, we can start scanning parts, scanning cutting edges, and things like that. But the next part of the demo that we're showing now is we're setting the workpiece. So we've set all our tools and updated all our tools, and so now we're actually setting the actual workpiece, where it is on the machine tool. So this is your conventional spindle probe that probably most people are very familiar with.
Going back to basics though, this is then reporting back to the machine control and setting the scene for what's then going to happen.
That's updating the work offsets. So then when we start the machining program, we activate those work offsets and we know exactly where that part is on the machine.
So you've got a start point, you've got your datums.
Exactly, yeah.
On the probe itself, on the tool probe, we've seen there that that's a fixed laser. I know that some of our customers wanted to move the probe out of the way, basically to make room so they could obviously work holding this, fill their table, and on the larger machines. Yeah. Is there an option for that?
Exactly, yeah. The system that we're showing here is the compact system, and it's actually the smallest one we do. That means the transmitter and receiver are the closest together for small tools. Yeah. We do them in bigger sizes so we can expand the gap between the two for accommodating larger tools. But you're quite right, we've done with you separate systems where we get the transmitter and the receiver sitting away from the machining area. So here we're on a demo, so we're able to just drop it on the table nice and casually, but really we want to, sometimes we haven't got that luxury, we need to keep it out of the work area.
Yeah. And you talk about Digilog a lot, obviously it's a name synonymous with BLUM Nova Test. Digital and analog.
Yes.
Analog, you'd be mistaken for thinking you're not going backwards. You know, when we're looking at everyday life, analog is old and antiquated, but that's not the case here.
No, it was a bit strange really, because obviously all probes, all standard probing systems are digital probes, so they're triggered or they're not triggered, they're on or they're off, they're digital. We brought into it an analog aspect, so we got a signal that we could monitor, which tells us not only if the beam is shaded or if the stylus is deflected, but how much it's deflected, and that allows us to actually accurately measure parts or accurately gather tool data above and beyond just saying yes it's good, yes it's no it's not good.
And we're seeing a lot of aspects of measurement in the show today. But you say that the CNC program can be modified to measure various workpieces within the same machine tool, providing for part setup, workpiece measurement, tool wear compensation, but there's also thermal compensation as well. I'm interested in that one. Tell me a little bit more about that and how that works.
Absolutely. Well, we can use these products, both the spindle probes and the laser tool setting system, the LC50. We can use that to monitor, obviously, any wear within tools or wear within movement in the part, but the whole thing is going to change thermally as well. So your cutting tool is going to expand thermally, especially with high-speed machining. And of course, you know, when you start your machine at the start of the day, it's a very different temperature than it is, you know, mid-afternoon when you've been cutting on it all day, and things start to adjust their positions thermally. So we can take all that thermal movement into consideration, compensate it, so we're making sure that the machine is always accurate and producing parts accurately, correctly every time.
Do you think engineers watching this program will know that? Hopefully they know you sell lasers. They'll know you sell probes. But do you think what you've just said there? Do you think the people at home are aware of that?
I think a lot of people will probably. They're certainly. I mean, engineers are certainly aware of the effects of thermal movement within a machine tool. But there are some quite complex solutions to allow you to compensate for that. So machines have built-in, you know, complex sort of thermal measurement, and then compensation tables to try and adjust this. But again, what we're able to do with just standard probing systems that are on a machine, we're able to measure dynamically live and compensate that movement, that change live in your machine throughout the day.
If you've got older machines, are you installing a lot of these solutions on older technology as well? And is that where it really scores too? Because if you have got an inaccurate machine tool, for example, you can get more out of it, you can get a better result.
Do you know what, Paul? That's a really good question, because what
That's
we
two
tend
good
to
questions.
find...
Don't say that, David.
Oh, okay.
Don't say that.
Paul, that's a terrible question. we basically, we speak to a lot of customers who kind of think, well, I'm buying the new super high-end technology, I need to incorporate this stuff onto that machine. This machine here is a really accurate, really repeatable machine. It's brand new, it's going to be good. Yes, we want you to have the benefits of being able to set your part and your tools in there, but it's actually, the benefit is going to give you better benefit, if that's a right phrase, on older machines, on machines that you've had on the shop floor for quite some time, really.
That's good to hear. I think we've got a question coming in.
We've had a question come through, and a nice shout out as well to Amni Ho for watching. Thank you. We've got loads of people watching across all of the channels. It is live, it is interactive, so thank you. So this is from a gentleman called Paul Hodgkinson. Great demo, so well done. Which industries and applications could benefit from this Digilog technology?
They can benefit all. Thank you very much for the question. That's nice to get some questions in. But obviously, people historically, and probably what people think of is in the higher end industries, and that's traditionally where we kind of have sold the systems and put the systems into. But I mean, automotive is going real high end. It's all about automation. It's basically when customers need to automate their processes, you need to be able to check what's happening in the machine tool and automatically compensate and change within what's happening there to keep an automated process. So it can fit in any organisation at all, really.
And Steve, on your QUASER machine here, you can see we've got an Aroa pallet pull. More engineers are looking to invest in automation.
Before we just talk, sorry to cut across you, but we're actually now, are we probing the part here now?
Yes.
So,
yep.
Sorry, Joe.
Sorry, yes. So this is the Digilog probe. So you will notice that it's the same probers that we used for setting the workpiece.
So we've just done that. We've probed the part.
We've probed the part. Yeah, we slightly missed it, but we then machined the components and using exactly the same probe. But now we're in Digilog. I'm not sure how clear it comes through on the video, but you can see that when it's in normal mode, there's a red LED on the probe, and when it's in Digilog mode, there's a blue LED. And when it's in Digilog mode, we're actually measuring, we're scanning the component. So we're going to scan that bore. So here it comes in now. Here's the Digilog coming in.
So what are we doing? We're now measuring again.
Yeah. So we measure the part again. So
David, I've just got a question come in from Sebastian as well. Does the probe communicate optically?
Yes, correct. We have two modes that we can communicate with. The system that we've got here is an infrared system. With the infrared system, we must have line of sight to the receiver unit, which is, you probably can't see it on the video, but it's installed up on the top end of the machine. We also can communicate with radio communication if line of sight is not so easy.
And just on this probing cycle, what can we check for? Clearly diameter, I think, but can we check for roundness and things like this?
Yep, absolutely. We can. The Digilog probe is a comparative probe. So rather than when we looked at developing this technology, we thought, well, do we want to actually have effectively a CMM in the machine tool, which is probably not really where people want to go. People in process measurement want to basically quickly say, yes, that's a good component. I can take it off the machine, it's a good component. So what the system is a comparative system. So what we would do is we would learn a good component. We know what a good component looks like. And then from that, we would actually then scan the part to check how it is against a good component. And then we can tell you, yes, it's good, no, it's not.
So is that happening? What are we seeing now? Just the part being measured once again?
Yes,
yeah.
So what we've tried to simulate on the demo is we've put a false error in effectively, because it's going to produce a part correctly every time. So we've basically put a false part in, we've measured it, and then we'll pick it up straight away on the system. The system will then automatically calculate what the error is, and in this case we're writing to the tool offset, but we can write to the workpiece offset as well. We're going to write to the tool offset, so we update the tool, and then we remachine the part a second time, so this time we've got a good component.
And it's worth pointing out, clearly behind there's no operator present. This is what I would call a closed loop process.
A key thing of really what we wanted to show really was, I think a lot of people kind of use the probes to measure the parts, measure the tools, and then maybe still interact themselves, still get in there, change things and modify themselves. And that's a confidence issue, if I'm honest. I think the system doesn't need any interaction. We can have closed loop automated control.
And Steve, we've got an Aurora pallet pull on this machine. People are looking to invest more in automation and less than human beings loading components. I guess you need this type of technology if you're going to automate. It's no good an end mill wearing at 2 a.m. and scrapping loads of parts.
Yeah, definitely. As we've done videos together before, the automation for everybody is gone on a dramatic increase, you know. Pretty much all the projects that we're involved with have automation or robot loading. So having the facility to have in-cycle process probing is a must really, because you can keep feeding the components in, but you need to be able to check the components. As well as obviously multiple pallets, you have different components that you need to probe and inspect. And as you touched on earlier, that closed loop.
Yeah, inspect's key. People say, you hear a lot, my parts come off complete. They're only complete if they're inspected. So if they're not inspected, they're not complete.
Correct, yeah. So the feedback really is you keep touching on is that closed loop process to get the feedback on whether it be tool life or datum setting or measuring the workpiece.
What about this scanning? I'm really interested in this. You know, how good is the scanning, and what industries would that service, and is it good enough for what sort of part? And I think we're actually seeing this now, are we, David?
Yeah, so what we're showing now is the roughness gauge. So this is using the Digilog technology, but to actually measure surface finish of the component. So the first scan we're going to do is on the rough part of the billet, the unmachined part. So the results will show you that you're detecting quite a rough finish, and then we'll rescan on that machined face, where obviously it's a much smoother position. We can see the accuracy that you can pick up on the probe. But it's all about with the Digilog and the roughness surface finish checking. It's okay us automating, so we can have automated loading system, as Steve was saying there. We can have automated unloading. If the part comes off and the part's not correct, we've got two options. We've either scrapped the component, which is disastrous, or we've got a component that we can save by reworking. But that means we've got to put it back on the machine, we've got to set it all up again, and we've got to remachine that part again.
And in terms, we've got software for this, haven't we? There's two options. You can have it on a PC, or we can actually have it on its own touch panel present by the machine.
Yeah, I mean, what we're showing on this demo is we're just running it on a standard PC, just so it's nice and big and we can see it. But we have quite a nice little solution where we have what we call our industrial PC, IPC. That's a PC that's integrated into the electrical cabinet, so it doesn't sit on the table at the side of the machine. And we have a little touch panel that we mount up somewhere near the CNC control, so that it'll show you the results, and you can, take any data that you need to take.
We have got so many questions coming in, so we're going to go over to Lindsay. Keep them coming. If we don't get to them all in this show, then obviously we'll be able to answer them afterwards too. But fire away, Lindsay.
Yeah, we've got so many questions. Right. Okay. So. What are the most common misconceptions around in-process measurement?
Good question, that one.
Excellent
That's
question.
not one of Paul's, that's a good question.
Yeah. Cycle time. Whenever we talk to anyone, they'll always talk to us. They'll say, this is a machine tool. And if there's any customers out there listening, they'll say, oh, Dave's going on again now saying the same thing. It's a machine tool. It's making me money when it's cutting chips, when it's making swarf. That's absolutely true. That's what we're about. What we're saying is, if it's cutting the wrong part, then you're wasting money, you're losing time. So we want to be cutting the right part, we want to be making sure you cut the right part, but we want to do that as quickly as possible so the most parts are coming off the machine. And the misconception is they think it takes too long to do it on the machine.
I hear that
Okay,
a lot.
so from Barry, how do you combat coolant and swarf interference within the process?
Well, the LC50 Digilog, this is when we first, Paul said at the start there, we first launched our first laser system 30 years ago. The very first generation we launched, we literally just blew air across the front of the laser. And very quickly we realised in a machine tool that's not going to work. So we then developed the shutter system, which is a little protective unit that sits on the front of the laser optics to seal the optics from the outside world. And it's a shutter that opens and closes as we need to do measurement. And the new LC50 has got an even more enhanced shutter system on there.
Okay, just a couple more because I know you're going through the whole process. So what are the tolerances that they hold in general on a day-to-day basis?
Sorry, I missed that on.
What are the tolerances that it holds on generally on a day-to-day basis?
The laser and the probe, the repeatability of the trigger points of those probes is sub-microns. We're talking 0.2 of a micron, something in that area. So absolute accuracy depends purely on your application. So if we put it on this brand new super duper quasar, we're going to get a better absolute accuracy than if we put it on a 20, 30 year old machine. But the system is always going to give you a higher accuracy rate than not measuring the system.
Is that down to the Shark 360?
Not all of the products have the Shark 360. That is a patented design that we've got. But the Shark 360 is about when we are using crank stylus. So if you want to measure with a sort of an application where we're using a crank stylus, you obviously are going to get two sides of deflection. We're not going to just deflect in the direction that we want to measure. We're getting some side torsional deflection. And the Shark 360 is a patented design to stop that happening, to give you utmost repeatability, really.
Okay, I do have quite a few more, but just bear with us because let's just continue and then we'll ask some of the questions at the end. But a massive thank you to Donald Donahue, Paul, Simon, Sebastian, Al, lots of you writing in as well. So I'll hand it back over to you guys.
Okay, I mean, I noticed a statement on the website where, actually coming back to your points, that reducing the need for manual intervention throughout the process, these products, they also help ensure you produce the right part the first time, and that's got so much value in that statement, isn't it?
It's got to be key. It's got to be key, isn't it?
This is the thing of it. I mean, people kind of use the first, how much it happens these days, I'm not sure, but people use the first part to set up to make sure that they've got everything set and moved, whereas we can set everything before you even cut the first part. So your first part is a valued, good component all the time.
Is there anything for if it detected a tool breakage, bringing in then a sister tool? I suppose that's where the machine comes into it, isn't it?
Yeah.
Is that something that can happen?
That's a really good option. To use sister tooling is a really good option. It's often an option that needs to be activated on the control, but there is ways we can do it through actual hard coding as well. But basically, if you set yourself a sister tool up and then run your production unmanned through the evening, through weekends, whatever, if the laser system identifies a problem, it goes into an error macro, and that error macro, we can define exactly what you want. So customer A will say to us, if it sees a problem, I want this to happen. And customer B will say, well, if I see the same problem, I want something different to happen. And we can set within that macro what happens on an error. And at that point we can stop it with an error, send it to a safe place and stop, alert the operator, or we can automatically call in an allocated sister tool and keep your production running.
And Steve, here at ETG, you sell a number of machine tool brands with lots of different controls. What's your experience been with BLUM on these various controls? Siemens, Heidenheim, Fanuc?
I'm glad you mentioned. I was trying to find an angle as to get that in as a customer of BLUM. And similar to ourselves, really being that turnkey provider and solutions provider, what's important to our customers is the backup and support. You know, you can't see in the background, but we've got the BLUM engineers sitting in the wings, you know, that obviously set this up for us. And it's why we have such a close relationship with BLUM, is because of that backup and support. Naturally, the customer has one point of contact being ourselves, but the times that we've had to have engineers out the same day or next day, we have a simple phone call into BLUM. Our customers have direct access to the BLUM engineers. So there's no, there's no call waiting list or emails and so
But
forth.
how about the programming itself? Like, I know it's been a while since you've been on the machine tour, no doubt, Steve, but you've got a real job. But it's when
real
you had
job?
when you had a real job.
When I had it, yeah.
He just pressed cycle start.
Yeah.
I'm asking for a pay rise.
He's still got it.
But
Still got it.
how easy are these cycles to implement into the machine tool?
They're fully embedded in the machine. So part of our process that the probes are fitted either here, or if we needed a quick delivery, we can retrofit them on site. All the cycles are naturally built in and all fully conversational.
And you've got behind you a Vulcan. You've been selling these now for some time and had a lot of success with them. That machine is a turning machine. You have solutions. I know we're talking prismatic parts here, but in that area too, is it the same sort of, the same processes?
I think in terms of the probing systems, that it depends on the application, but sometimes on turning applications, you can obviously get a lot more vibration in there. Mm-hmm. So we have probes that are specifically designed. They're built off the same concept of what we run in here, but they're a special version for turning machines. We call them basically the same probe, but with a /T for turning. And all that is we stiffen up the measuring mechanism slightly, and we put some anti-vibration collars in there to just dampen the effects that you're going to get from the harsher machining that is often found in turning. Not always, but often.
It's a very good question, because I would guess the majority of your sales would be on the milling machine. Perhaps they are, perhaps they're not. That would be my perception. But the first time I came across the RG Digilog, the roughness gauge, was in fact on a turning centre.
Yes.
And it was saving that particular company tens of thousands of pounds. Well, it was a few years ago, it'd be hundreds of thousands of pounds now.
Yeah, I know the application that you are referring to there. That was a case of using the Digilog probe, which is the scanning probe we've got here, and they were producing a thread. Quite a simple part, not overly sort of accurate, not overly complex, but they were having to stop, open the doors, and the guy was having to manually check the part using a manual gauge. And now our probe goes in and scans, and their throughput is just increased by an incredible amount. But it is interesting you say, yes, traditionally BLUM work on milling machines. Our German colleagues that are watching probably are already putting pressure on us to get ourselves more and more turning activity, and today we do quite a bit on the turning side as well.
Any limitations? Any machines you'd have to look at and say that's not for us at the moment?
Only from a retrofit point of view, really. From a retrofit point of view, when we go to these machines, we need certain I/O within the machine to allow us to be able to switch on and off the probe and put it into different monitor modes, especially when you go to the Digilog range. And if you've got an older machine, you might not have the I/O available. We are working on solutions at the moment that make retrofitting easier. But when you're talking brand new machines like this, it's pretty open for anything.
Yeah, we have actually had a question on that. Can a tool setter probe be fitted to any machine? I have a 2002 Bridgeport and spend a lot of time putting tools in and out of the carousel. It only has 22 stations.
Absolutely, yeah. We know Bridgeport quite well, don't we, Steve? There, so we've done a fair few Bridgeports over the time. Absolutely, Bridgeport, working with a Bridgeport, probably high 9 controller. I don't know, but yeah, we have a full solution. And you don't always have to go to the full laser system. You can go with tactile measurements as well if you want simple. It can still give you huge benefits, put it this way.
Okay, we've got lots coming through, so we've got about less than 10 minutes left, so do keep asking questions. We will get to them, if not on the live stream, after as well. But Lindsay?
Absolutely. Okay, so is the Surface Rough Stylus different to the Measurement Ruby?
Yes, it is. Essentially, the probe is the same. It's exactly the same probe. The only difference is we change the stylus and the software that does the monitoring. So in theory, you could use one probe and change it, but then we would lose automation.
Well, this was going to be a point for me, because you've got maybe 20, 30 stations in your tool carousel. If you start putting 2 or 3 different probing solutions in there, you're going to lose what you're gaining from having a bigger tool changer. So what you're saying is the two can work as one tool in one tool holder.
This is because I know that the systems on the market where you would use the standard probe, if we can call it that, for part setting, and then you would flip to a scanning probe for actual dimensional checking of a component. So you need two probes in the machine for that application. the beauty of Digilog is you only need one. It does both operations.
Okay.
Yep, some more questions. Don't forget, Steve's got a bit of an announcement to make in the next 10 minutes as well. So do you provide, great question to be fair, on all the systems, your after sales and support? And what support is this?
What support was that you were asking?
The after sales support and training?
Yep, absolutely.
Do you provide it all?
This is, for us, this is something that's absolutely key, and what we base ourselves and our whole sort of ethos, if you like, in the UK market. It's all about the backup and support. It's all about being able to phone someone up and actually speak to someone who knows the application, not a service call centre where someone's very nice but ultimately unable to help you with what your particular issue is. All our engineers, when they install the kit, they leave their business card with the customer, which has got their direct email address and it's got their mobile number on it. And the customer is free to phone them directly, so not through a service centre, a call centre. They can call them directly, and they were the guy that put it on the machine. They were the ones that know exactly how it's connected, what you're trying to do with it, and instantly know, can engage with you in supporting that product straight away.
David, this machine, it's fast, it's nimble, it's quite a harsh environment, isn't it? Lots of swarf and coolant flying about. So what sort of longevity are we talking with these products, the lasers and the probes?
We see the laser system, if we take it from that side, the laser diode has about 10,000 hours lifetime. So we're talking many years. We've got lasers in the field that have got a serial number, date stamp on them that are more than 25 years old. Still operational, still fine, absolutely no problem.
Lindsay?
So if you, with the whole shooting match, you could lose several stations in your carousel. Is there not a universal tool that scans, measures and does everything other than losing 2 stations?
I suppose that's a bit similar in some ways, but a good question to what we'd covered before. Again, trying to keep it all in 1 or 2 stations in the tool carousel.
Yeah. So I think I heard that was talking about not using up the carousel. Is that what we're saying? Yeah. So the Digilog allows you to do much more functionality off one probe, so you don't have to have multiple probes in the device. Also, although it's not to the full automation level that we like, that some people can always keep the probe out the machine and just load it in as required if they're not doing continual measurements, repeat measurements all the time, really.
Sorry, Steve, go on.
Go on. So the Digilog software, we're obviously running it on the VMC, the simple 3-axis application. Can that be used on a 5-axis machine as well?
Absolutely. I think a lot of people probably think of Digilog of only really being a benefit if they're using 5-axis machines, but it's not true. And we're demoing it here that we can use it on a 3-axis machine. So all that's in the field really can benefit from Digilog. But it can be used on full free form, 5-axis measurement or standard simple products really.
Okay, we are literally just a few minutes left. We're going to go over to Lindsay, as I did say. Do keep the questions coming in. We will get to them at some point, but over to you.
We have had loads, thank you. Angelo, I hope I know what you mean here. What tolerance can be describing the error of the probe in different positions?
Okay, so I think he's probably referring to lobing characteristics of the probe, and it's a very good question. So this is key. This is absolutely key because lobing, for those people who don't understand what lobing of a probe is if you measure with a probe to get absolutely accurate results, so you're not taking any error from the trigger signal of the probe itself, they would say that you want to be probing in the same direction for every feature. That's fine if I've got like we're on the demo here, we're showing just a bore and we're just touching on 4 pieces of a bore. That's fine, we can orientate the probe to make sure that we're always probing in the same direction. As soon as you go to 5-axis machining and the full axis head and the part is moving into a real complex position, we don't know that we're probing in the same direction. So lobing of the probe becomes a key issue that you've got to watch. And this is something when we designed our probing system, we worked very hard to make sure that it was what we call a non-lobing probe. That means you can probe in any direction, 360 degrees, any axis orientation, and you'll get no error from the probe. What you measure will be an error in the part, not in the probe, and it's very critical.
He is good, isn't he? Right, okay, I've got 2 more questions. Right, how regularly do you recommend calibrating your probe in a 5-axis application?
We have customers that never calibrate, and I've told them many times, but they don't listen to me. But we have customers that calibrate, every day. We would always say at the start of the day when you first go in, start a calibration cycle. We're not showing the calibration cycle on here, but the calibration takes about 15 seconds, something like that. If you start it and go and make yourself a cup of tea before you kick off the machine, it'll be done well in advance if you're coming back. So every day we would say.
Okay, and one more. Can these probing cycles be used with third-party CAM systems such as Fusion 360?
That's a really good question, actually.
Yeah, it is, absolutely. This is a big area that we're developing now. We're working with the CAM systems where we're integrating these probes into various different systems. That takes time because there are many out there. We've completed several already. I would say if you contact us, we can tell you what's been done. But on the ones that haven't yet been done, we're working on developing cycles that integrate within that. And that's key as we start to talk about automation and going to the next level of for automated programs.
Okay, now I want to come on to Steve now. I know there's other things coming through, but
there is lots of questions, but thank you, and thank you everybody for messaging in. But you can contact the team directly anyway.
Yeah, but Steve, tell us then what you said at the start about something happening in July in conjunction with the pair of you.
Yeah, so with partnership and the support of BLUM and basically everything that we've just discussed today, and allowing all our viewers and customers to benefit from it. Any machine tool purchased from within our portfolio and our brand, we will be putting a complimentary BLUM probing package into that machine tool for anything that's order placed within July. And they will take advantage of everything that we've just discussed today and give us an opportunity to demonstrate the probes and the backup support they'll get.
Good stuff. And David, are you seeing is this a big growing area, this in process? When people are now looking to automate things, they're looking at, keeping operators away from the machine and maximising productivity?
Absolutely, yeah. I think automation is the buzzword, isn't it, that everyone's kind of talking to. So we've been banging this drum for...
2-0 was a buzzword as well.
Yeah, absolutely, yeah. We've been banging the drum for this for many years, but people are starting to realise that, reshoring is the other word. People want to start bringing back production here, but we've got to make things more accurate, which we've got to make things more economical. We've got to be right first time. We can't be reworking. We can't be scrapping parts, and so we can use automation, robotic systems, cobots, and things like this. We can use to load and set machines. But if we're producing the part wrong, we defeat everything we've done is defeated. So we've really got to make sure the parts coming off the machine are right first time. That's what we're about. That's our tagline.
The announcement, a very impressive announcement, I must say there, but I was hoping for World Cup final tickets, Steve. I thought that was the big announcement.
No, mate, no.
That's August, is it?
Yeah. I was opening an invite to the England game last night, but I didn't get that, so you can still be waiting,
well, on
Joe.
that point, I would say thank you very much, guys. They think it's all over. It is now. Over to you, Lindsay.
Yeah, thank you very much. So, of course, you've got that lovely deal, shall we say, from the Engineering Technology Group that's going to be happening throughout July. Thank you so much for watching. We really, really love all of your questions coming in. And if you do have any more questions, put them on the bottom of the screen as you have been doing so, and we'll get David or we'll get Steve to answer them directly for you. Thank you for watching. We've got lots of lives coming up in the diary as well, so keep an eye out on the MTD CNC channel. We'll see you very soon.